second lecture of design of steel structure. So first of all, in the first lecture, we will discuss about our chapter number 1, which is the loads and load combinations. Okay. Now in loads and load combinations, there are two theories are there. So some revisions of the lecture number 1 is now. So in the first theory we will discuss about types of load, and you all know that there are number of loads like dead load, live load, wind load, earthquake load, snow load and impact load, and other secondary effects like crane loads, accidental loads and fire load and other secondary effects are there. So in the first theory we will discuss about types of load, and in types of load there are mainly three types of loads. First one is vertical loads, second one is horizontal loads, and third one is longitudinal loads. Okay, so in the last lecture we will discuss about types of load, and after that we will discuss about them in briefly. Okay, now in second theory the question is the types of load combinations consider while you have to design any steel structures. So students, this theory is basically covered from your IS Codal Provisions 800/2007, in which the solution of this theory is given on table number 4. Okay, so you all the students are moved to table number 4 and how to convert this table into the solution of this question. Okay, so these two theories are covered in your lecture number 1. Now it is already discussed in your last lecture that there are total 6 modules are there in your subject. So your first module is completed over here. Now we are moving further to the next module, and this next module is your last module of this subject. So now we will discuss about your last module, which is your module number 6. So the name of this module is plastic design. Okay, and from Atul Prakashan book, the chapter number 7. Okay, so now we will move to chapter number 7, which is plastic design. So students, it is already discussed that this plastic design chapter is somehow the similar and the base of the MOS and structure analysis. Okay, mechanics of solid and structure analysis, in which you have to study about kinematic indeterminacy, redundant, it is capital R, number of equilibrium condition, which is small r. Okay, so all these things are covered in this chapter, and after that we will derive some equations like when the wind load or when the any point load, if any point load, the point load value is capital W, is acting on the center of simply supported beam, then what is the equation? So you will directly take when the point load is acting at the center of the beam and your beam is simply supported beam. So your equation of moment is capital W into L divided by 4. So this equation is derived in this chapter. Okay, and there are total number of equations derived in this lecture. So students, now we will moving further to this chapter, in which your first theory is concept. Okay, before knowing any introduction or any subjects, first of all you have to find out what is the concept of this chapter and what is the concept of this theory. Okay, so your first theory is concept of plastic design. So now moving further to the concept of plastic analysis and design, in which your concept is in elastic method of design. Okay, In elastic method of design, or it is also called as working stress method, or it is also called as allowable stress method, in which the stress and deformation are computed at working loads using the elastic property of steel. Okay, so this is the basic concept of plastic analysis theory. And you all know that there are number of methods like limit state method, working stress method. Now, what is the difference between limit state method and working stress method? So, the main difference is like this: the in working stress design limits the structural usefulness of steel up to an allowable stress, or allowable stress is also called as permissible stress, which is well below the elastic limit. Okay, now what is the main advantage or main funda of plastic method? So you can see that over here in plastic method of design, ultimate load. Okay, ultimate load is denoted by capital W and U. Okay, U for ultimate and W for loads. So in plastic design, ultimate load is taken as the design criteria. Okay, now the main advantage of this plastic design is the plastic method of design gives an economical design. Okay, so you all know that whenever you have to design any building, then first of all your mindset is your building is safe, and at the same time your building is economical. Okay, so the main advantage of plastic design is economical. Okay, now for next theory, what is the assumptions are made whenever you have to design for plastic? Okay, so whenever you have to design for plastic method, so your material. Okay, so what is the criteria for your material which allowed your building is for in plastic limit? So the assumption, these all are the assumptions which you have to made. So your first assumption is the material. Your material, whether it is steel beam or steel column, is obey. Obey means follow Hooke's law. Okay. Your second assumption is your yield stress. Now you all know that stress is equal to force divided by area. So your yield stress short form is Fy. F for stress and Y for yield. So you can see that over here this is yield stress. Okay. So the yield stress and modulus of elasticity have the same value in compression and tension. Okay. So this is the main important assumption whenever you have to design any component for plastic method. Okay. Your third assumption is the material is homogeneous and isotropic in both plastic and elastic states. Your fourth assumption is plane traverse section remain plane. Okay, even after bending, if you have to bend your material, your plane traverse is remain plane. Okay, and it is because of its elasticity. Okay, your fifth assumption is the cross section of beam is symmetrical about an axis through its centroid. Okay, so this is your fifth assumption. Your sixth assumption is there is no resultant axial force. Okay, your next assumption is influence of normal and shear force on plastic moment is not to be considered. Okay, and your last assumption is no instability occur. Okay, whenever you have to use any structural members, then no any instability occur in that material. Okay, So these all are the assumptions whenever you have to design for plastic method. Okay. So this is your main theory. Now you have to derive some equations. So for that, your next theories, name of this theories, explain fully plastic moment. Okay. So your theory of fully plastic moment, in which first of all you have to assume one cross sectional area having some unequal shape. You can see that in this figure it is equal shape, but you have to assume that this is unequal shape. Now you all know that whenever you have any component, its CG is exactly at the center of that point. So the weakest point is a center point. So we have to cut this component from center. Okay. So this upper portion and this is downward portion. Now you all know that tension is occur at the bottom portion and compression is occur at the top portion. So now this is your top portion. So in top portion compression is generated and in bottom portion tension is generated. So the distribution diagram like this is compression. So the value of this C means force. Okay. Now you all know that stress is equal to force upon area. Now, if you have to find out force, then the equation is stress into area. Okay. So this is compression force. C for compression is equal to Fy. Fy means yield stress into A1 because the area of this portion, upper half portion is A1. So your compression force is Fy into A1. Now similarly, your tensile force is at the bottom half portion. So your tensile force is Fy. Fy means yield stress into A2 because A2 is your area of bottom half portion. Now, whenever you have to design any component or any material, your main focus is your material is remain safe. Okay. So whenever when your material is remain same or safe, so when your compression force is equal to your tensile force, then your member is in similar position. Okay. So for balance section, compression force is equal to tensile force. Okay. Now what is the value of compression force? The value of compression force is Fy into A1 and the value of tensile force is Fy into A2. Now you have to delete this Fy portion. So your equation is A1 is equal to A2. And you already see that in this figure, you have to cut your figure from the center. So obviously it is A1 is equal to A2. Now what is the total area of this parabolic portion? So you have to assume that the total area is A. It means your total A1. So this is your upper portion. So this A1 plus A2 is equal to total area. So you can also write that over here. Capital A is equal to A1 plus A2. But in the upper line, it is already derived that your A1 is equal to A2. So you have to put A1 is equal to A2 in this equation and you will get your answer. A1 is equal to A2 is equal to A by 2. Okay. Now, your question is fully plastic moment. The word is moment. And you all know that moment is equal to force into perpendicular distance. Okay. So now your moment is equal to load into perpendicular distance. So your total plastic moment of this parabolic portion is moment due to compression portion plus moment due to tensile portion. Okay. Now moment is equal to force into perpendicular distance. Okay. So your total moment, it means total MP is equal to moment due to compression plus moment due to tension. Okay. Now Fy into A1, this is the value of force. Okay. It is already discussed over here. Now Y1. Y1 is this distance from the center. Okay. Because the center of is A1 portion is exactly at that point at the center of this portion. Okay. So this portion is Y1, and similarly the center of this bottom half portion is at this point. So from the center of whole the section and the center of the second portion, bottom portion, the distance is called as y2. Okay. So Fy into A1 into Y1 plus, similarly for tension member, it is Fy into A2 into Y2. Now your Fy is common, and you already derived that A1 is equal to A2 is equal to A by 2. So you have to put the value of A1 is equal to A2 is equal to A by 2. So your A by 2 is common in both the faces. So your A by 2 is also common. Okay. So your final equation is Fy into A by 2 in the bracket y1 plus y2. Now, very most important term, you have to convert this A by 2 into y1 plus y2 is also called as ZP. ZP means plastic section modulus. So, your final equation of MP is Fy into ZP. Okay. So your one term is a ZP. So ZP is your plastic section modulus. So the equation of plastic section modulus is A by 2 in the bracket y1 plus y. So students, this is the end of your fully plastic moment theory. Now we are moving further to three definitions. Okay. So these three definitions are very most important for GTO point of view. So first definition is what is shape factor. So these three definitions are you have to make in your mind. Okay. So the shape factor is the ratio of plastic moment to yield moment. Okay. Now plastic moment short form is MP and the yield moment's short form is My. Now, what is the equation of MP? The equation of MP is already derived in the last slide, and it is Fy into Zp. And similarly, for My, it is Fy into Ze, not Zy over here. Okay. So, Fy is cut, and your equation of shape factor. So, shape factor is denoted by capital S, and it is Zp upon Ze. So this is your first definition. Now we are moving further to your second definition, which is load factor. Okay, load factor is also called as the factor of safety. Okay, now the equation of factor of safety or equation of load factor is like this. So it is capital WC divided by W. Your capital WC is called as collapse load divided by working load. Okay, or it is also called as WL upon W, in which WL is also called as collapse load, or it is also called as WU divided by capital W. Okay, so this is your second definition. Now the very most important definition is your collapse load. So generally all the students are make this definition like this: the load at which the building has to be collapsed is called collapse loads. No, you have to return this definition like the load at which a sufficient number of plastic hinges are formed in a structure such that the collapse mechanism is created. Okay, this collapse mechanism means the number of load combinations are there which force to collapse the building. Okay, so created is called as the collapse load. Now, what is the equation of collapse load? The equation of collapse load is capital W into capital F. It means your capital W is your working load and capital F is factor of safety. Okay, so students, this is the main three definitions of this chapter. And so now this is the end of today's session. Thank you.